The input to your transition function is, now it'll be an ordered pair, right? So it'll be the current state, comma, what you're reading, the head. What is the head reading? Well, it's a 0, it'll be reading this. Okay, so Q1, comma 0. Q1, can you see this? Q1, comma 0. Right? So you'll go this way. You'll transition to state Q2. There it is there. And you'll overwrite the 0 with a blank. That's the blank here. So this 0 becomes a blank. And you move to the right. Alright? So whatever the state here will move to here. But the 0 got overwritten by blank. So you've got blank here. And here's the state now. And that, unchanged. But the state got changed from Q1 to Q2. So now you're here. Okay? Right, now you're in state Q2 and you're reading a 0. So you're in state Q2 and you're reading a 0. Alright, overwrite it with an X and shift right. So overwrite it with an X, so that 0 will become an X, and you shift right. So the state now will be between the second last and third last 0. It'll be sort of here. Okay? So the Q2 went to Q3, and so on and so on. Okay? And there are 21 configurations until you get there. Now let's see. Now, going from configuration to configuration, or if you like, Turing machine step by step. Very low level of detail, and so you need to step back a bit and ask yourself what the bigger picture. You might look at a block of these, the whole hunk of them, and you could call them like stages. Like in this stage, the header moves from right to left. It heads back to the leftmost position. You can call that a stage, and it does that in a series of steps. Things like that. So you need to be analysing at multiple levels. The high level, the grand strategy, so to speak, and at the very low level of state transitions and transition rules, that kind of thing. And you need to tie the two together, and that's an art. That takes practice and intelligence and creativity, right? So let's see what's happening here. So you are crossing off every second. Or maybe you're crossing off every other. Well, the text says every other. So that means you might be crossing off the first one, and then the third one, and the fifth one, rather than the second one, the fourth one. So, see, this was a 0. So you're crossing off every second one, right? So here, see, it did not get crossed off because it was in Q3. Did not get crossed off, and then Q4 went to Q3, and it did get crossed off. So if it's in let's see what's happening. If it's in Q3, don't cross it off. If it's in Q4, well, let me put it this way. If it's in Q2, cross it off. And if it's in Q3, we've now got a complication because, well, if it's in Q4, what are we going to do? We cross it off. Yeah, we cross it off. And then go to Q3. But now what we're reading is the blank. So we know we're at the right-hand end of the string. Okay? And once we do that, we know the next. So you could call that a stage, if you like. You're scanning across from left to right. And now we hit the end here. We know it's at the end because now we're reading a blank. And now we need to head back. So we're in, let's say, a different stage. And so this state here, when you're hitting the blank and you know you're at the end, we'll then go to a new state. And see, figuring out when to go to a new state, that's part of the art of the design. So we're now in a different state, so Q5, and we're going to and while we're in Q5, we just stay there. We don't scan anymore. We're not modifying anything on the tape. We're just heading back to the left-hand side. Okay, so well, we could actually do it. Let's see. So Q5X. What should we do here? We should just move. That's it. So we'll probably have a transition rule that where the label on the transition arrow only has 3 marks, because we're not changing what's on the tape. Right? We're just moving. We're just moving back to the left. So I can predict, without looking at the transition table, what it should be. So Q5, comma X arrow. The transition rule will be, so the triple will be, it'll stay in Q5, so it'll be Q5, comma X, comma L. Right? Because we're moving back, we're moving left. Okay, let's check that. So Q5X, where's Q5? Q5X. Alright, so it'll go back to Q5, right? It's reading X. And the move is L. So here's your shorthand label on your transition error. So that was correct. Okay. Now you can do this for yourself. You just go through it. Well, that's still getting globally. So now the header is here, and then it's here. It's heading back to the left. So the Q keeps shifting to the left. So then it's here. And finally, you get this one, and now the header is over the leftmost blank. Sorry, it's over the blank, so it's reached the edge of the tape. That's the symbol in the first square of the tape at the left-hand end. Okay, so what do we do now? Well, then we just go through the whole thing again. We go through another scan and come back. Loop. Okay, so we go back to Q2, we go back to that loop, and we just do it again. And this time we'll knock out the 0. And you need to be keeping count. How many zeros have you seen an even or odd number of zeros? And you do that with your Q2 and Q3, I suspect, right? So as you can see, now I won't go all the way through. So you're back in Q5. Where's that? Oh, because you hit the end. Okay, Q5 is going back. Okay, so another loop of Q2. So you just keep scanning through. No zeros until again. So the number of zeros you've seen is 0. Well, that's even. Okay. And no more. Now how do you know it's the end? How do you know it's all X's? Where's that? Was that mentioned? There may be more subtleties here than meets the eye. So yeah, you really have to think about when you analyze how a Turing machine works, and even more so, well, when you design the thing, right? The usual trick, you be yourself the Turing machine, and you go through the process and you try to cover every possibility, all the fringe cases and so forth, right? So you're in Q2 and watching a blank. Oh, I guess that's how you know, because otherwise you'd be in Q3. Let me check that. Yeah, see here when you reach the blank, you're in Q3. And you're in Q3 because you have seen a zero before, I guess, right? But you stay in Q2 when you've seen no zeros, I guess. So that's how the machine knows. And then it's still in Q2 and it sees a blank, and therefore it knows it's succeeded. So it goes to so this one is what it's reading here. And you can keep the header can keep reading to the right. There's lots of squares there. So this the header is here. It's over the last. Hold on. It's over the first blank after the string. The first blank after the string. And so what's it doing now? So it'll move right again. So it's now. Well, that's it. Once it goes to accept state, you don't bother what's happening after that, because as soon as it goes to accept state, it stops. Right? It's a Turing machine. That's what Turing machines do. Right. So I hope. Well, I put a comment here. Now this is me. It's not Sipser. You begin to see why a TM full formal description or descriptions are rarely given unless the Turing machines are tiny, right? Because it's a pretty small machine, and already it's quite tedious. So now the next session will be another example. The state diagram will not be complete, otherwise there'd just be too cluttered, too many states in it, and it'd just look like spaghetti. But interestingly, this oh, wait a minute, I'm getting ahead of myself. So the next one, what's it doing? Oh, it's a return to our M1. So you see, this was M2. So we go back to our old machine that we were using to learn what a TM is, and we will now give a quasi-full, not quite, because at least we do provide a state diagram, but it's not complete. Because otherwise it would be too cluttered. But the problem is, remember, for machine M1, the language was W hash W. So your task is to see if the string W on the left-hand side of the hash is the same as the string on the right-hand side of the hash. That was the task. So we'll do that next session.